So I will just be very short and introduce Wookey, who will now give you an embedded Debian presentation. Wookey.
Okay, hello everyone. So, I work for LF1. We do embedded development for anybody who'll pay, and we try and base it on Debian when they'll let us. I've been interested in this for a while. I'm nominally project leader for the last 3 years or something, which means very little has happened in that time. But I'll tell you where we are and where we're going. Before we start, how many of you already know all about embedded development? Well, you know, are interested, have done some, know what we're talking about. And how many of you, this is a kind of new area and you've got some widget, you just think it would be cool to put Linux on? Okay, a few of each. So, to some extent, I've got you here under false pretenses today. The talk was billed as, it was suggested to me, in fact, by Lars Wisnius that what we should do to encourage Debian to support embeddedness would be demonstrate all the cool things you can do with embedded widgets and how easy it is and why we should all do it. So I thought that's a good idea. But I've just spent, so the idea was I'd sit here and show you how to download the tools and install a toolchain and configure it for cross-building, build a kernel for your little widget, download all the sources, and then explain about how cross-building works, build a rootfest, stick it on the machine and it would sing songs or whatever. And you'd all be suitably impressed and could go home and do it yourselves. So I spent the last week doing that. We got as far as installing a toolchain. That worked quite well. Fixed a couple of things. Configure for cross-building and try and build things, and no, nothing worked at all, really. It was all a disaster. So the current state of the tools is that lots of things don't work. If you want to do, as I just described, then go and use Scratchbox or Open Embedded, because they actually do work. If you want to try and do it the pure Debian way, it makes life difficult for some reasons I'll go on to explain. So what I'm actually going to talk about today is, so plan B, the reason why I haven't got all this working and marvellous and beautiful is that I spent most of the last month fighting software patents and not preparing this talk or working on embedded Debian or anything else I was supposed to be doing. So that's my excuse for any disorganization that may occur in the next hour or so. This worked quite well, though. So we had a major success on that front. So the backup. This is what you'll get. I'll just explain what embedded Debian is for those of you who don't know, and tell you where we got to, and explain some of the pros and cons of this approach, what we're trying to do, how it's supposed to work, and what we need to do next to actually make it work. And one of the things I want to, we kind of got into it in the previous session, I don't know if there's anyone who's here who wasn't there, about why Debian supporting embedded stuff more than it does now is probably a good thing for everybody. So, embedded Debian is an official sub-project. It's all very exciting. The idea is that lots of people who are already familiar with developing the Debian way they use it would like to just be able to produce a mini version for a specific purpose. There's an awful lot of companies like mine that you know, people who don't know about embedded systems but have realized that they probably want to use Linux on their hardware need easy ways to build a system with this stuff on, or alternatively, we build them a base system that they can put their special thing on. As someone mentioned this morning, you know, people often have a great deal of expertise in their particular application area, but they really don't know about building basic Linux systems. In principle, Debian ought to be a good base for this kind of thing. Partly because of the multi-architecture support and all the tools we've got. The other thing, of course, is that it all has to be proper free tools, none of this Monte Vista and their secret configuration system, which is proprietary. Started in the year 2000 by a guy called Frank Smith from Amerix, who thought basically what I think, that this would be a good idea. And they produced a tool chain that worked for ARM and PowerPC, I think. And also a handy tool called, I'm sure that should be mdebsys, which is quite primitive, but it's also quite neat. Basically, you use the kernel configuration language and extend it into user space, so you can configure which tools you want, whether you want ping or mount or whatever, and then it just goes and fishes the relevant binaries out of the Debian archive and puts together a rootfs. And the problem with that was keeping it in sync with the changing packages was a real pain. So inevitably it got left behind by both the kernel and Debian. Also, it was written in CML2, which never made it into kernel favor, which put it at something of a disadvantage. It did get updated to the new kernel config language, and people have used it for real commercial projects. You know, it works. And it's arguably one of the best ways of producing a really small system is positively fishing out the binaries you want, as opposed to building packages and throwing away the bits you don't want, because it guarantees you don't end up with anything you didn't really need. Since then, we basically started again with a new scheme using dpackage cross and a thing called the Stag framework, which is basically the work of Philippe de Sweert, who unfortunately isn't here today. And we've been fiddling with that for, I don't know, a year and a half now. There's also been new tools, which is mostly the work of Nikita Yushchenko. So people used to use well, all sorts of cross-compilers from all over the place. But it would make a lot more sense if you used the standard Debian source. So somebody did a thing called toolchain source, which was a package which was basically just the toolchain source from which you could build a cross-compiler, which is all right, but it tends to get out of sync with the compilers people were using in the rest of Debian. And obviously it was much smarter to actually build the cross-compilers from the same source package that we build the normal compilers, which after all is something that the upstream source can do, so our packaging ought to be able to do it too. So Nikita fixed all that, so now we can build cross-compilers for all Debian architectures from the same source. They may even work. They're all available on mdebian.org. And obviously, increasingly, for a long time, basically, you wanted an x86 compiler to whatever target you want to use. But these days, there's more than one fast development machine you might conceivably be using. So hopefully this week, we'll get the PowerPC and AMD 64 development host versions working. So you'll have from all those three fast architectures to all the weedy small ones. Now, we don't want to put all of those tools in Debian because there's an awful lot of combinations. You can work it out, 11 factorial or something, which hardly anybody needs, especially all the ones like, you know, you really don't need a cross-compiler that runs on ARM and produces x86 binaries. That would be dumb. So trying to put all of them in the Debian bucket is just a waste of space, really. So we'll just host them on mdebian.org or somewhere useful. So reasons why Debian isn't really where you want to start. It's all built natively. There's good reasons for that. It's because it works. It's simple. That's the way everything was designed to be done. But embedded developers really don't like natively building. I mean, you can do, and indeed, it can be quite practical if you have a fast enough target machine. So if you've got a fast ARM box, you can build your ARM binaries on that. And it does save a lot of aggravation. And that's how quite a few people I work with actually operate. You can buy a 600 megahertz ARM desktop box, which will compile everything, you know, pretty slowly by modern standards, but still fast enough. But in practice, most embedded developers need to be able to cross-build things. Normally, Debian doesn't care at all about the size of binaries. Oh, we care a little bit, but basically people go, you can't buy a hard disk smaller than 40 gig. You know, why are you complaining about a couple of 100K here and there? And the answer is, of course, because that thing's got 64 meg of flash in it. So your entire file system has to fit in 64 meg. In fact, it's got to fit in 60 meg because you'd quite like some data of your own. So there is a dramatic difference. I mean, embedded used to mean 32K. You know, these days it means like less than 32 meg. So it's got a lot bigger, which is why Linux has become practical in embedded systems. In your average standard Debian package, there's a whole load of stuff that you don't need on your average embedded system. All the documentation, most of it, example files, Vim coloring schemes, 27 languages that you aren't going to use, all that sort of thing. So you want to be able to get rid of that. And by default, we tend to enable everything. So if it's possible to use something with X, then it will be compiled to do so. Or with some fancy font mangling system or whatever, all of that stuff. And again, people want more control than that, and often might not, on a lot of systems, there is no display. You don't want any of the X versions, but you still want the underlying functionality. Reasons why Debian's good. The code base is nice, everything's consistent, files are where they're supposed to be. I mean, that's why a lot of us started using Debian in the first place. I know I used to hate Red Hat. It was a great revelation to find that config files were always actually in /etc where they were supposed to be and not somewhere bizarre. All that stuff, I mean, to some extent I think that has gone upstream and the world's a tidier place than it used to be in 1997. But even so, it is nice. And you know it builds on all the architectures without aggravation because we checked. The multiple architecture support's good. A lot of the targets people are actually using embedded systems supported in Debian, not all of them. People do use weird stuff like SH4. Actually, have we got SH4 build? People had one for a while, but I'm not sure it's defunct. There are... but in practice, most people are using ARM or PowerPC or 68K or x86, of course. And our management tools are quite nifty. If you start to look at how it all works, we can in fact do most of what's needed in terms of cross-building and installing packages not to the default file system, but to a target file system, all of your own, a chroot or whatever. It's all there, and it's a matter of bringing together these tools so that it works in a coordinated way. As we were discussing earlier, we quite like having derived distributions. It provides useful ideas and feedback and gets things fixed that wouldn't otherwise be fixed. And the familiarity of developers is one of the reasons why they quite like to be able to use something like Debian on their small devices. You know, not exactly the same, but having a lot of the things they're used to. So people who don't come from that background are quite happy to use any strange embedded system you give them, whereas people who are just used to Linux looking like Debian kind of like their other boxes to behave in a similar way. So that's the main target, I think, is people who are already Debian users but do embedded things and want easy ways to prototype systems. Embedded Debian probably isn't the best way of producing general production embedded systems. There's something like Open Embedded, I think will always have much finer grained control over what you can do, because absolutely everything is possible within that framework. But it is horribly complicated, even by our standards. And it would be nice if we could produce something that let people prototype stuff quicker and easier than that. So, to make this work, we need a scheme to cross-compile things that doesn't break horribly. Dealing with optimizations, generally things are optimized for speed, whereas for embedded system you probably want to optimize for space. And in fact, it might go faster anyway. There's arranging things so that you can manage the packages on the target device, which of course aren't going to be the same set of packages as on your host device, build device. There'll be a small subset of them, and as we'll talk about later, actually a slightly different arrangement potentially. So you need some mechanism to say which bits you want. Splitting packages up into smaller pieces helps a lot. So you have all the languages split out into a separate little language package, and the docs split off, and the X version split off, and so on. The finer grained your package management is, the more easier it is to get the bits you actually wanted rather than a whole load of stuff you didn't. One of the things that we kind of think about regularly at these events but haven't reached final conclusions on, I don't think, is the packaging namespace. So if you take Debian installer as an example, that is basically an embedded system based on Debian, but it's designed to live in the same namespace. You know, all the Debian installer packages exist in parallel with the normal packages because of what it's designed to do. But in a lot of cases, you probably don't need to do that. And what you actually want to do is build a whole separate namespace, a set of packages for your particular target, which don't have to work with Debian ones. On the other hand, there's a set of people who want to be able to prototype something quickly using a kind of standard base system, a standard small base system, and then stick in random Debian packages for obscure or complicated stuff because it's not in our little mini build. And if you want to do that, you've got to have a compatible system. So you've got to be using the same libc. You can't be using UC libc and then stick in random Debian packages and expect it to work. I mean, you can do that to some extent, but that's making it a lot difficult. So there's various ways you might want to do this, and you probably can't support all of them at once. It'd be nice if we could, but we certainly, to start with, we've got to pick something and do that and prove it works before trying to satisfy all conceivable schemes at once, which just makes your life so difficult that you never get anywhere. One thing people do want is a customization mechanism for their particular device. You know, for the reasons of all the derived distributions we're talking about, there's always some stuff you want to change. It might just be the kernel. It might be some kind of unified graphical goodness for the front end on your little widget. So a kind of organized way of applying your set of patches so that you can keep porting that forward as things move on easily will be a very nice feature. That's something Open Embedded does really well. It's something that's relatively difficult to stick into the depackage cross kind of Debian way of cross-compiling things because we have one dirty great big patch instead of piles of little ones, which is what you really want. Staying in sync with Debian is the other thing. There's a very small number of people actually working on this at the moment. That's one of the reasons it's progressing fairly slowly. And Debian keeps moving on, and our tools get left behind. And once we have a whole load of changed packages, if those changes aren't kept basically in Debian itself, then in practice it'll just get left behind immediately and become useless. Embedded Debian will only work unless, if either several hundred people start working on it, or we have a mechanism for keeping the changes from standard Debian within normal packages, and maintainers actually looking after those changes. So for that to work, we have to get a fair amount of buy-in from Debian that this is something worth doing. So there's two major issues which are largely independent. There's cross-compiling things. Now that's useful for embedded people, but it's useful for other reasons too. As I mentioned, if your build Ds are sufficiently slow, you might actually want to cross-build that architecture just because you can do it in a hundredth the time. I think it would also be, gives the same benefits to Debian that building for a lot of architectures has given us in the past. You know, nobody else used to do that, and it meant that Debian was the only thing where you could guarantee everything worked on big endian and little endian and different sizes of pointers and all the things that vary across architectures, the fundamental stuff. An awful lot of those bugs were pushed upstream over the years as we've discovered that things were broken because people only write for the architecture they know. you can't necessarily be expected to know that ARM has really strange float format, which we're finally getting rid of. So all those things that have got fixed over the last decade, we can now not care about anymore. So I think if we decided that Debian should be cross-buildable and fix things accordingly, because the mechanisms all exist, they've been there for a long time. There's an awful lot of crap in or cruft in autoconf and package config and all that stuff, which in theory means cross-building should work the way it's intended, but it doesn't for a lot of detailed reasons, like people never try it, and nobody understands autoconf, and just copy the scripts from somewhere else, and you know, the same badness that everybody else had. An awful lot of the fixes are in fact already in Open Embedded because they've been going through this process for a year and a half. There is a great load of goodness in there which tells you what needs changing to make things build properly. And to some extent they're pushing that upstream as well. So
What about stuff that is intrinsically async run?
So, yeah. Do you want to save this for the end, if you can remember? Because, yeah, I think there'll be quite a lot to talk about like this. You're right. There is a whole load of stuff which has to be run at build time. There's lots of things, build stuff and then run it for tests. And there's a limit to how much of that you can do without creating a whole target environment that looks like the target environment and running things in it, which is what Scratchbox does. And I think we want to use a lot of the good things that Scratchbox has done. But to a large extent, well, I'll talk about that more on a later slide, actually. And the other part of this is package modifications, which is throwing away the docs at the most primitive level. So you can have a lot of basic heuristic rules which say throw away all the examples, throw everything in user share. We don't care about that except for about 6 files that are actually important, which will do the right thing for a lot of packages. But for in a lot of cases, you'll need specific rules for a particular package that say the way it should be done for a small build is like this. And in fact, we want 3 different versions of it for different purposes. But these 2 things, the cross-compiling part and the building shrunk packages part, are mostly independent. So what we're trying to do is reuse the existing package management system, depackage and apt, and add cross-compilation support, which in fact already exists in the form of depackage cross, which is a tool designed to just build with depackage build package. You just add a couple of options and say build it for ARM. Remove the stuff we didn't want, and have a scheme for installing the packages either onto the development host for testing or on the target itself. So you can either build your root file system on your development box. So you make all your packages and then you install them to the sort of virtual target, and then you copy the results across onto your actual target. Or you can make packages which the target can install itself. So there's 2 different models. It depends whether you want to just make a widget and give people a system image, or whether it's kind of like a PDA and they actually want to be able to have a set of packages which you can choose things from and chop and change. So the things we fiddled with, right, these slides are now going to get in slightly randomized order, so I do apologize if it becomes a bit disjoint. That's the fault of software patents. Depackage cross is this thing that has existed in Debian for a while. I think it was originally produced for people who just needed to build like an ARM version of a particular package in order to do a porter's binary upload. But nevertheless, it's basically a wrapper for depackage build package, which sets a whole load of stuff and can fill in config variables and generally do arbitrarily complicated things in order to set all the things that should be set, such that if your package build system is properly constructed, it will just spit out the right thing at the end. As Scratchbox buyers can tell you, life is nothing like that simple in practice, but the principle seems reasonably sound. It automatically means that the build system is told to use the right compiler and the right bin utils and the right strip and all that sort of thing. So the way we've implemented this is basically just wrappers for dpackage and apt, which give it the right options. So this is what your the standard setup on your normal Debian box. You have your repository with binary and source packages in it. You can get a list of those packages, which apt puts in a local database, so you know what's available. And then you get those into your local cache. You can build them, or you can just install them. And there's a database of what's installed. You know, we all more or less know how that works. So to do that for the embedded setup, we have basically the same thing but slightly more complicated. So now there's a second repository list for the target architecture and a second locally available database for the target architecture and a second local database of installed packages for the target architecture. So, you know, it's not difficult. And that way you can manage the set of packages on your device separately from the set of packages on your machine. Now, apt and dpackage already provide all the technology we need to do this. We don't have to write any new software. It's great. Now, why wasn't that the next slide? Because I'm rubbish. Oh, and how do I go backwards? Right. I'll show you that in a minute. So the way you do this, you download your sources and build everything on your development machine. The parameters which control the cross-compiling live in etc dpackage cross-compile, which tells it which architecture it should be, assuming you have a default one, and where the toolchain lives, and stuff like that. And it, in fact, also provides a mechanism for special versions of things, which I'll come to in a minute. That's quite a new feature. You build things with dpackage build package the way you did before. And then there's a wrapper around dpackage for actually installing the packages you've built into your local target system. On the actual device, when you get later, so you haven't needed your device at all up till now, but when you finally dig it out and make it work, you can use iPackage to install those packages rather than dpackage if you want to save the phenomenal amount of space you'll save by doing that, because dpackage's databases are very large, especially when you've got a lot of packages. iPackage is a lot more efficient in that regard, but it's basically compatible, so you can choose which one you want to use on the end device. You can't use iPackage for all this build stuff because it's not smart enough. So this is the neat new feature that's been added to dpackage cross recently, which is basically you can have a set of modes. Basically, you can have arbitrarily complicated flags for all sorts of purposes. It's very generic, but there's a special Debian flag, which basically says all the tools that you normally use for building. So this affects deb helper. If we got round to it, it would affect CDBS and any other obscure build schemes which we don't know about. Can be told things like, by default, throw away the docs. You know, by default, remember to link with the target architecture libraries and not the host ones when doing dpackage libdeps and generating all the runes. So because a lot of the packages are built with the same tools, by changing those tool scripts a little bit to just make them cross-compile aware, you get quite a lot of this almost for free by basically setting this flag. So that bit works, or at least it was working in February, but since then something's changed and it's now broken again, as I discovered this week, which is why I'm not going to demonstrate it by actually typing it, because all you get is obscure runes about not being able to set cross-prefix to cross-prefix. But you can also specify in the scope here all the extra flags. So if you want to build everything with -M CPU strong arm, or you want to add soft float or other compiler flags, basically you stick them in here and they get given to every single package that gets built. You can specify a different C library and so on. So that's the kind of fundamental control level mechanism. So this is how the wrapper stuff to make apt do all that stuff about retaining a separate set of lists for the architecture. You know, it's not very complicated. You tell it what the apt architecture is, and that it should be using a different sources.list, because you probably want to get your file from somewhere else. 15 minutes, Jesus, right, okay. And that the cache is somewhere else, and so on. And that anything that gets installed to a different place from the default root file system. Basically the same with dpackage stag. Sorry, dpackage, there's a wrapper for it which just gives it the right runes every time. So that does quite a lot of what you want at the basic level. So there's a fundamental problem of how do you control the bits that are different for embedded builds. Now we kind of hummed and hawed about this. We're now on the second generation of the scheme, which I still view very much as an experimental implementation. So at the moment you have your Debian directory, which contains the control files and stuff, everything you need to build, Debian rules. So now we have an mdebian directory as well. So if an mdebian directory is present, then the tools, these new tools, will use that preferentially. So that's how you get to have different packages, different dependencies, and different build options. The problem with that is because it's a separate directory, it's not at all obvious to your maintainer that there's all this, you know, basically we've got two copies of a lot of information. We could copy the standard rules and then change them a bit, and those will go out of sync horribly over time. If anyone can think of a much better scheme, the main advantage of this was that we could tack it on to existing packages without getting anybody's way. So we could experiment with this system, prove it was actually valid, and then worry about trying to. And you know, we could get that into people's packages without it changing anything at all, one jot of their work, which would be relatively painless, we were hoping. So that's the advantage of this scheme. It's entirely non-intrusive, but it may not be the best way to keep maintenance in the long term. So the package doesn't change much. We add this mdebian subdirectory with new build info, which is usually very similar, but just slightly different. Blah, 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 told all that. Splitting the docs out is a good thing because, as Timo will tell you later in the week, the docs produce an awful lot of circular dependencies in Debian, which makes it incredibly hard to build the whole thing from scratch. You have to have Debian already in order to build Debian. It's a bit of a pain for embedded systems, where you really would like to be able to build the whole thing from a tool chain up, from glibc upwards, because that way it definitely comes out right. So the way you actually use this, you install your modified tools, modified deb helper and dpackage gross, set that mdebian flag, and then just build things with a -a arm instead of what you normally did. And in principle, it spits out all your Debian packages for another architecture. As I observed earlier, that generally doesn't work except for extremely simple packages. And that's where we're going to have a session afterwards and sit around and hack some things and discuss about stealing a number of the good bits out of Scratchbox, especially the ability to run non-native binaries in order to do compile time tests. The multi-arch stuff I think is also very interesting in this regard. You know, it's primarily aimed at x86 and AMD64, but in fact you can also get it to run ARM test binaries during the build, which could be useful. So yeah, so as I said, the tools will improve packages from our point of view without you making any changes to them at all. And then there's a more specific set of changes you can make if necessary. So these are the scripts that need modifying in dpackage dev, because all of them need to know about basically just knowing about the mdebian directory as well as the Debian directory and using it preferentially if it exists. It's not rocket science, actually. If you look, you'll find there's lots of trivial little modifications to all the scripts. So things that don't work so well. Depackage cross, as I say, was really designed, so it's a handy tool. If you need to build something for ARM, you need to have all the libraries it needs, at the very least. And depackage cross basically lets you get those libraries from the existing architecture pile. So you already Debian already has all the ARM libraries pre-built. And it's just, you can basically do depackage cross package name. It'll fish out the library files and package name and architecture. It'll fish out the library files and the header files and package config files for all the libraries you need, stick them in the right place so that the cross-build system will just find and use them. What it doesn't have is a neat way of actually sucking the binaries in the first place. As far as I can tell, you have to go to packages.debian.org and download them with Wookey each time, which is incredibly rubbish because we have lots of other tools that sort of do that, like apt-build, but I couldn't get it so that it would just get the few packages you need for this particular build dependency. Apt would get carried away and go, no, but if I need those, I need all these, and I need all these, and then it says, right, we'll download 336 megabytes of packages, basically an entire system. And you go, no, I don't need an entire system, I just need the stuff for this package. Now, that could just be because I'm very stupid, and someone will explain to me later what the right rune for that is, but it was annoying me this week. You do need to be root for a lot of this stuff to work, but then that's kind of true for package building anyway with the fake root stuff. I can see that it could be a problem in some environments. It kind of depends whether there's lots of developers trying to use a system or if it's just you and your box, in which case it probably doesn't matter. If we put in runes for an awful lot of packages, the fact that all the bodges for cross-building something properly go in etc, so it should be depackage, cross-compile, it's going to get to be a very big file after a while if we've got little secret runes for 1,000 packages in there. So it probably needs splitting up, but that can come later. The other thing I think that needs a bit of thought is on embedded systems, almost invariably, you don't use a whole load of the base file stuff, you use BusyBox instead. And you don't tend to use standard xlibs and x and all the associated cruft, you use tinyx instead. So there's a kind of base system which you will usually want to use, which has a fundamentally different set of dependencies. And I haven't quite got my head around exactly how we're going to do that. I'm sure we can, but it needs somebody smarter than me to explain to me what the correct runes are. So once you've generated a whole load of these packages, then you use stag-get, as I mentioned earlier, which will you just do stag-get arm update, stag-get arm install package, and it'll just take your packages from the pile. So once we have produced an example embedded Debian, we can do a standard one, which will probably satisfy a lot of people, which is basically Debian, probably 500 packages from Debian that people actually use, and a much smaller base system with BusyBox and tinyx. Then most people can just point stag-get at that and use it, and that way they can produce embedded systems in about a quarter of an hour. And then they put their one application on top that they actually want to use that's new or different. That's the idea. Where are we? So we have the tools to do this, but they don't work very well, which is why I want smart people in this room to come and have a good hack later so we can at least get things up to date and see how much of a system we can build that works. We have a build machine, which is 5 minutes, right? Okay. Does that include questions as well?
Yes.
Right, okay, I better shut then, hadn't I? I'm nearly at the end, which is good. And we need to actually build an example distro that people can try out. That means making a list of the packages that people actually need. I'm not sure what the minimal set of packages is, But making a list, say, these are the first 200 that we ought to compile, and then that will satisfy a lot of people, or 500, however many it is. Adding QEMU, actually, I mentioned earlier. Diddly-doo. Yeah, we covered that pretty much. Somebody from Debian installer ought to come and help, because I haven't taken enough notice of exactly how they've done what they've done, and I'm sure that we ought to make sure that we're not inventing things which they've already worked around. And the other thing is that ultimately the Scratchbox guys are well ahead of me on this. They've been playing this game for a couple of years already, and I've discovered that it's hard work, and doing things this way is difficult. So basically Scratchbox works around a lot of these problems by not fixing all the broken build systems and just providing a big sandbox so that the broken build systems still do the right thing, which is very cool. But what I'm kind of interested in is whether it's possible to actually fix all the build systems and do it kind of cleanly and properly with rather less stuff needed to make it work. I don't know. Maybe it isn't, in which case, you know, those solutions are in fact already the best way of doing it, and I should just give up with this. The other thing is, can we persuade everyone in Debian that cross-compilability is a good thing? Because if we can't do that, this probably isn't going to get very far. And can the changes we make to Debian be kept in step with Debian as it rushes along in its headlong epicness? Again, if not, we have a problem. We'll just keep getting left behind, and we'll never get anywhere. There are all sorts of odd build systems out there. Most of this stuff should work for autoconf and for debhelper, but when people do exotic kind of build it and then build it again from the results of the amazing makefile, which built all your Debian makefiles and stuff, life will get difficult. These people have all helped out. ONS has provided the build box we've got somewhere in the States or New Zealand or somewhere, I don't know where it is, but basically we've got a box we can play with. That's that, right. Jolly good. Questions? Oh, yeah, okay. As we went to all the trouble to make it appear on the camera. So this is just an example system, which we didn't build with embedded Debian, of course, because it's rubbish and doesn't work. This was built with Open Embedded. But this is the kind of cool stuff you can do. This is 64 mega flash, packed with Firefox and a proper email client, which is...
Do you think that we can see it up there?
Oh, you're supposed to be able to see it up there. Yeah, sorry. Magic technical people, make my thing appear.
We also had a question.
Yes.
Okay, so
Someone ask a question.
yeah, okay, so where are you thinking of putting all the configure variables?
There's a whole in etc dpackage cross compile. You have all the configure variables for a particular architecture, and for Linux. Oh, sorry. Yes. Repeat the question. Where are we going to put all the configure variables? Dpackage cross basically takes care of that. There's a set of files. So there's one for if you're using Linux, configure variables look like this. If you're using ARM, configure variables look like this. So we can add an arbitrary set of those files. If you're using embedded Debian, some configuration variables look like this.
So that go DKG cross.
That's right. So that's a feature of dpackage cross. All right, so we've got our netbook. So this is a quick 30-second demo just to show that you can do quite neat things. We should have the Nokia people here because theirs is even cooler, I'm sure, because it's newer. So this is a whole load of apps. This is the GNU Palm Top environment plus Mozilla, Abbey Word, Gnumeric, GPDF, blah, blah, blah. And this little thing in the corner, Therian Editor, is a scheme which basically means you can stick in. So that's what fits in 64 mega flash. But if you've got things that don't fit, so Therian is an extremely obscure one of my packages in Debian for drawing cave surveys, which requires TCL/TK and all of TETEC and a whole load of garbage. And basically, you can just fish all of that stuff out of Debian, standard Debian packages, stick them on a compact flash, and put them in, and add a little app icon, and that appears and runs. So you can add a random vertical app to the basic system slowly. So this is a strong arm 400 megahertz PXA thing. As you can see, GPDF runs really, really quickly. But it does work. And what this gives you...
That's the video bandwidth.
It is, yeah. So that's Therian TCL thing finally started up. Mozilla goes fast enough to be, you know, quite usable. It's a little bit sluggish, but it works. And what this lets you do is have all the stuff you need on a basic system. So text editor, email, web browser, PDF reader, calendar app, blah, blah, blah. You know, in 64 meg stuff. And that was built with Open Embedded. And it took, I don't know, about 8 of us 8 months or something. Yeah, that was a big job. We spent a lot of science money on that.
Solitaire on it as well.
Does it? Oh, yeah, so it does, yes, indeed. So, you know, and to be fair, this included a lot of work. If you look at the standard version of Balsa, it's got a lot more menus and options and things. This has had a human interface man go over it and basically throw away most of it, saying, you don't need that, don't need that, don't need that. People don't know what any of these things are for. Get rid of them. Hide them in extra menus that say more at the bottom. Here we are, like that. You know, so all the extra cruft that used to live there is hidden from your normal user. And quite a lot of the work went into that. And that's the sort of thing where Open Embedded is good because, you know, there was some fairly heavy patches. But, you know, it's got a mechanism for basically keeping your dirty great patch for your special version of the applications. So anyway, yes, that's a cool toy.
Can you run OpenOffice?
It does, yes. So OpenOffice goes in on the compact flash card. That's what the mechanism was devised for.
Can you run it now?
And I haven't got that on this card, I'm afraid, because I was much more interested in cave surveying than OpenOffice. It does run it very slowly.
I'm sorry, but we'll have to.
We'll have to
wrap
stop
it up
there. Okay. So the thing I do need to say is there will be a Hackfest for the rest, well, Tuesday and Wednesday and the rest of today on embedded Debian. So anyone who's interested in this sort of thing, please come to wherever the hacking is. There's a room for it, I gather. Smoky, yes, Smurky or something. And we will be there in the corner playing with this stuff. Thank you.